2NURFM, a broadcast service of the University of Newcastle.
Join us, as always, Professor John O'Connor. Good morning, John.
Morning, Mark.
Look, this is something that's got my interest. It sounds to me almost like something out of the Terminator, and Skynet have got in control, but this is about some self-healing materials.
Yes,
What's going on?
This is part of an evolution because most of us have got phones that are pretty solid. You drop them and horrible things
don't
happen.
I know it?
and already we're starting to get electronics which are made out of plastics, so they're bendable. And that's great because you want to have shapes other than dead flat, which is what most phones are. And they're a bit more, being flexible, they're a bit more resilient. But they're already working on, and in fact they're reporting at the American Chemical Society meeting about materials which go beyond that, and they're stretchy. Now, it's a bit of a challenge because it's not just making something that's stretchy, because we've got that already, rubber, plastic, all sorts of things.
Sure.
What you want to do is to have something which is stretchy and a conductor. And so that then really narrows down your options. But they've managed to do that. They've come up with long-chain polymers and ionic salts, which, when they mix together, have, first off, they can conduct. They can, current can flow through them, usually in terms of the ions rather than the electrons, but that doesn't matter. Mm-hmm. That still works. They are stretchy in the sense that they can be extended up to 50 times their original size. But more importantly, if you break them and you put them back together, they rebond. Now, all of these together make a really interesting prospect.
They really do. This is sort of amazing stuff. I mean, it's revolutionary, really. What are some of the real-world applications that we can expect with this technology? Well,
if you had something of this form, then you don't have to have something that stretches 50 times. I mean, that's just showing its extreme capability. But the thing is, if you dropped it or if it had some failure and you put it back together, they've actually demonstrated with this material, you put the two pieces back together and within 24 hours, they've rebonded. So you imagine, you drop something and break it and you just put it back together and you leave it there, a bit like setting it with glue, leave it for 24 hours, you come back and it's working again. That would be brilliant.
I'm already seeing all of those mobile phone repair shops in the shopping centres going out of business.
But also, there are wonderful opportunities in terms of robotics. I mean, these things could form artificial muscles in robotics, for instance. So, yes, it's not only a possibility of repairing and overcoming repair shops, and the expense and voiding your warranty in your phone as a consequence.
Yes, that's true.
That's the other issue. But yes, you have the possibility of actually creating artificial muscles for robots, which is always a challenge, because how do you get a robot to work like a human? And there are certain things that can do that. And if they use motors, they're a bit clunky. You want to have something where you apply an electric field and it bends or it moves or whatever, much like our muscles do.
You never know where an idea is going to come from, and you were telling me before we started this morning that the idea from this was kind of spawned from movies as well.
That's right. One of the researchers was saying that he was really impressed as a child by the Marvel comics and the X-Men in particular, and how there are situations where they would be damaged and they'd re-heal very quickly. And he thought, wouldn't it be great if we had materials like this? Now, things like silicon don't do that. They're as brittle as glass. You snap a bit of silicon, doesn't matter what you do, putting it back together, it won't work. And other plastics, either if you do break them, you can't put them back together, or they again are brittle. This particular plastic is one that he's worked on. His first application is looking hopefully at repairing batteries for mobile phones. So if a battery gets broken, it can be a serious problem, because it potentially either doesn't work or it could create a problem which involves a fire or something. So if you actually have rehealing batteries, then they would have the capacity to perhaps live longer, but also be much more resilient to a bit of damage.
You got me there. Batteries living longer. That's all we need right there.
Too right. Yes, certainly. And that's one of the challenges with batteries is that as they keep going through cycles, they change. And if you can lengthen the number of cycles they go through, that really improves their economic benefit. And that's one of the limitations in terms of whether it's worthwhile putting batteries into a system, like storing energy from solar cells and so forth. The number of cycles it can go through really determines the economics of it.
We will wait and wonder with this technology to see how it goes, and who knows, maybe we can get a few people to snap back together as well. Maybe.
The scary thing about this is, as with other times, I've spoken about these things on this segment, and almost no time at all it suddenly appears. So it's scary. Just look out for it. It's going to happen soon.
Well, you're ahead of the game. You're setting trends, John.
Thanks, Mark.
As always, Professor John O'Connor talking to us about mathematics, science and technology here at 2NURFM 103.7.